Hi friends, today we are going to discuss about the different types of the cross validations in machine learning. So today topics are the what is the cross validation and why cross validation is important and different types of the cross validation techniques. So here four different types of the cross validation techniques we are going to discuss. Those are simple cross validation, leave one out cross validation, K-fold cross validation, and stratified K-fold cross validations. So what is meant by cross validations? So cross validation, it is a resampling procedure. So resampling procedure is to evaluate the machine learning models and assess how the model will perform on the test dataset. So here resample procedures. So under the resampling procedures, some of the techniques are called train, test, splits, and cross validations. Cross validation sense K-fold cross validation, stratified K-fold cross validations, like that. So cross validation is one of the resampling procedure. It is used to evaluate the machine learning model and assess how the model will performing on the test dataset. The cross validation is a statistical technique that can help to improve the model accuracy in machine learning, and one of the more advantage of the cross validation is you can control the overfitting problem. So the training phase is the most significant part of the machine learning. So if you are not training on machine learning model with good constraint, it will give you the worst results. So when you not supposed to be trained properly the model on the training dataset, the model will give the worst results. So the cross validations can be applied on the trained dataset only, but not apply the test dataset. So I will tell you. Why cross validation is important. So we randomly split the data set into the trained data set and test data set to develop the machine learning model. So for developing the machine learning model, we have to divide the data set into train and test data set. So the trained data set is used to train the ML model. The same model is tested on the test data set to evaluate the performance of the model. So by using the training data, we have to train the model. The model is applied on the test data set. We have to check the evaluation of this model. So with the change in the random state of the split, so the accuracy of the model will also change. So we are not able to achieve a fixed accuracy of the model. So what does it mean? So here dataset can be divided into two parts. Train data, for example, 70% of the data is for training. So remaining 30% of the data for the testing purpose. So when 70-30, 70% training part, 30% for the testing part can be used with the random state. With the random state, if you supposed to give any number, like for example 1, so the accuracy will be 80%. Suppose 70% of the training, 30% of the testing. The random state, if you supposed to give 0, so then accuracy it may be 82%. The same percentage, and if you take the random state is equal to 100, So the accuracy may be changed about to 85. So here, what is it? What do you understand? So even the training and testing percentage is same. The random state is supposed to changing the value. So every time the accuracy is also be changing. So means there is no constant. So that is the meaning. So with the changing in the random state, so with the change in the random state of the split means with the changing the value of the random state, so the accuracy of the model will also be changing. Yes, accuracy of the model changing from 80 percentage, 82, 85 like that. So we are not able to achieve the fixed accuracy of the model. So the testing data should be kept independent of the training data, so no data leakage occur. So when you keep the testing data from the training data, so there is no data will be leakage. So during the development of the machine learning model using the training data, the model performance needs to be evaluated. So that's why we need the we came to know what is the importance of the cross validation data. Next, simple cross validation. This is one of the cross validation technique. So it is a very simple technique. It is a very simple technique. So we split the data into training and test data set. So we split the data into train and test data set with the 80% or 20 percentage or 70 percentage or 30, 75 or 25 like that. So we use the 70 to 80% of the data for the training. So 70 to 75 80 percentage of the data we are supposed to for the train the model. So 30 to 20%, 30, 25, this is the percentage of the data we have to use for the testing the model. So this technique is not good at all time for training the ML model. So what is the disadvantage of this technique is we can't get the same result for all time if you don't specify the random state, and we don't know how the data is distributed. So here main disadvantage of the simple cross validation, we always getting the different results. We can't get the same result always. Why? Because if you are supposed to changing the random state, so the values of the accuracy of the model are going to be changed. So that is the drawback of this technique. So here the data needs to be split into two parts, training data and validation data. So this validation data is also known as the test data. So training data is used for model development, means to train the model, to train the ML model. So validation data used for validating the performance of the same model. So on the training data set, means about 80 percentage of data you have to split for the 80 percentage of the data for the training, remain 20 percentage of the data for the testing. So we have to train the model on by using an 80 percentage of the data. So 20 percentage of the data we have to perform the validation on the validation data set. So and another approach is the leave one out cross validation. Leave leave one out cross validation is also known as LOOCV. So this is the exhaustive cross validation technique. So for the dataset having the n rows, for example, here I am taking the n is equal to 5 rows. 5 rows means this is the 5 rows. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the first row is selected for the validation and the rest of the n-1 rows are used to train the model. So this is the part 1 we can use for the testing purpose. So remaining 2 to 4 is for the train in first iteration. For the next iteration, so this part we have to use for the testing. So remaining from part number 1, 3, 4, 5 is for the testing and training. So in the next third iteration, so this third row we can use for the testing. So remaining rows 1, 2, 4, 5 is for the training. So similarly, this process is repeated until the n steps. N means here 5 steps. So this is the leave one out cross validation. So what is the advantage? So it is a simple, easy to understand, implement. But the drawback is the model may lead to the low bias and its computation time is very high. Why? Because suppose here in real time if n is equal to 1 lakh rows. So every time among the 1 lakh rows, so one row for the testing, remaining 99,000 for the training in one iteration. So like that, so many iterations has to be taken for giving the result. So that's why it is a computationally time is very high. That is a drawback of the leave one out cross validation. Next, another approach is K-fold cross validation. This is a very famous technique. This technique has follows this 5 steps. The first step is we have to split the data into train and test dataset about to 70 30 70 by 25 80 20% of the data. And as a general rule, k is equal to 5 or 10 is preferred, but not fixing, but nothing fixed it. You can take any value according to your problem statement. So now we will resplit the train data into train and test data according to the K-fold. So here step one means first this is the data. This data is divided into two parts, train and test. This training data is for 80% of the data for the training, 20% of data is for the testing. So here step number 3, now we will resplit. So resplit the train data. So here 80% of the data means the train data we have to take in and apply the cross validation here. Apply the cross validation. For example, here n k is equal to 5. So the 80% of the data we have to take in. So in the 80% of the data we have to apply the cross validation. So here k is equal to 5 means 5 parts. So first part is used for the testing, remaining used for the training purpose. So like that we have to perform the cross validation on only training dataset. So cross validation has to be performed on the training dataset, not performed on test data, not performed on the test data. So calculate the accuracy of the each k-fold cross validation. So here 80% of the data we have to take in and apply the cross validation. So in the first iterations it used for the testing, so remaining used for the training. So remaining used for the training, so the training part is applied on the test data set. You got the accuracy, that is the accuracy one. And if you take one more, so in the second part used for the testing, so remaining boxes are for the training, and you will get the one more accuracy too. So like that, how many Ks are available? So if here K is equal to 5, 10 like that. So here K 5 means 5 is groups. Otherwise K is equal to 10 means 10 groups. If it is 5 means 5 accuracies. If is K is equal to 10 means you will get the 10 accuracies. So if it is 5 accuracies, you can take the average of the 5 accuracies. If it is 10 accuracies means if you take the average of the 10 accuracies. So that is the step number 4. Calculate the accuracy of the k-fold cross validations. So step 5, the final accuracy of the model is computed by taking the mean accuracy of the K model validation set. So here accuracy CV is equal to sigma I is equal to 1 to K. Accuracies are all accuracies by the how many K folds. So that is the K-fold cross validation. So what is the advantage and what is the pros and cons? This model has the low bias and it has the low time complexity. So compared to leave previous method leave one out cross validation, so it is the low time complexity, but it is not suitable for the imbalanced data set. So for K4 cross validation not suitable, not suitable for the imbalanced. So that's why even that is the scenario we have to take the K stratified K-fold cross validation. So to overcome this issue, so means imbalanced data, so it is not suitable for the imbalanced data in the K-fold. So this kind of drawback can be overcome by the stratified K-fold. So here K-fold used in regression problems. Stratified K-fold used in classification problems. So stratified K-fold cross validation. So it avoids the drawback of the K-fold cross validation. So in stratified K-fold cross validation, the data set is partitioned into K groups or the K-folds such that the validation data has been equal number of instances of the target level process. So which means this ensures that one particular class is not over present in the validation or train the data, especially when the data set is imbalanced. So, and the final score is computed by taking the mean of the score of each fold. So, what does it mean here? So, in this data set, for example, here, uh, first here, in this stratified K-fold, this is one kind of 1 K-fold, 2 K-fold, 3 K-folds, 4 and 5. So here K is equal to 5. So in first iterations, this part is used for the testing. So remaining part is used for the training. So you will get the accuracy 1. Similarly, here also you will get the accuracy 2, accuracy 3, accuracy 4, accuracy 5. So finally, you take the average of 5 accuracies. So here the main point is here in stratified K-fold cross evaluation, the data set is partitioned into K groups. Here K is equal to 5 groups such that the validation data has an equal number of instances. Means in this data, for example, this is the column 1, column 2, and this is the target variable. So in the target variable, for example, in this one fold, so what are the proportion of the target variable in the testing part, which is also be maintained, is which is equal what percentage of the class labels of the target variable, the same proportion is also be maintained in the training part also. So don't be confused, I will explain clearly. If you take this one, so here I'm taking the data set, column 1, column 1, column 2, column 3, column 4 and column 5, which means this is the total 5 columns. Under the 5 columns, 4 columns, column 1 to column 4, these are the input features, input variables, and the target variable, this is the fifth column, this is the fifth column, target variable. The target variable has some labels. Target variable has labels. So if it is a classification problem, it is a classification problem, especially for the binary class. So binary class means the target variable has only two class labels, like yes or no, male or female, positive or negative, 0 or 1, like that. So in this kind of binaries kind of problems, in you have to suppose to apply the cross stratified K-fold cross validation. Actually, in the K-fold cross validation, if you see, actually this data has total 30 rows. total 30 rows. So here what I am doing, I am dividing this 6 rows one batch. 6 rows is equal to 1 batch. Here from 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So 6 rows belongs to one batch, means here one fold. Similarly, 8, 1, 2, 3, 4, 5, 6. Similarly here, so this part is the 6 observations. This is batch 1, batch 2, this is batch 1, this is batch 2, batch 3, batch 4, batch 5, totally 5 batches. So in the 5 batches, 30 rows by 5 batches, total 30 observations. So each batch has a means k is equal to 5, which means each batch has 6 rows. So in the 6 rows, suppose if you take this first batch, batch 1 means this green color we consider as a test data. So remaining this so batch 1 used for the test data. So remaining 24 observations consider the train data. So remaining 24 rows, if you have to take the train data, and you will get the accuracy 1. So next time, this blue part can be considered as the test data, and this green part, red part, and blue part, yellow part can be considered as the train data, and you will get the one more accuracy 2. In third instance, third iteration, so the red part can be considered as the test data, remaining green, blue, and this color and yellow color can be considered as a train data set. So similarly, we have to do all folds. But one most important point is why you are using the K-fold in classification, which means suppose this part used for the testing and this part are used for the training. So this 80 percentage of the data you have to train the model. After training the model, you have to apply it on the test data set. So in the test data, suppose here in the binary classification, here yes, all are in one class. So at that time you will get the worst result. So at that time you will get the worst result. That's why we have to maintain the some equal proportions. So equal proportion has to maintain in target variable, which means if 60 to 40% maintain in target variable of the training data, then the same percentage means 60 to 40. 60 to 40 percentage also be maintaining target variable of the test data. So here the proportion 60% to 40% is this proportion maintained done by the stratified K-fold. Here in this target variable, so this is the target variable. In the target variable, so this is the yellow part is the used for the training. So in this training partition, in the 80%, for example, 80% of the training data, so in the target variable, the target variable of the binary class is the 101010 like that available. So what percentage here if you have to maintain, for example here maintain the 60 to 40% of the 60 to 40 percentage maintain in the target variable. So this is the target variable, maintain the target variable of the train data. The what percentage you have to maintain here, the same proportion also be maintained in the target variable, but no need to do manually. The stratified K-fold is maintained this proportion is maintained in the stratified K-fold. So in this way we have to, the stratified K-fold is working. The stratified K-fold is applied in the classifications. Let's see in practical. For K-fold cross validation, I am taking the regression kind of step on dataset. So here all are the sales is the target variable. So TV, so one advertisement. So they're spending some amount on the TV advertisement, radio and newspaper. How much sales they are doing? So this is the data set. So in this this is the regression problem. That's why we are using the linear regression. So here what I'm doing, I'm dividing the dataset into train dataset and test dataset with the 80 to 20 percentage. So tested data is 0.2 means 20 percentage. I'm applying the linear regression and fit the model on the X train Y train, and this model is applied on X test Y test. You got the 91 point. If you see the random state here, random state is 100, you will get the 91. So here random state is equal to 100. How much accuracy? 91.8. 0.84%. If I change the value 0, so accuracy is 86. If the random state is 0, the accuracy is 86.011. If the accuracy, if you give any number, for example 7, accuracy is 90. If you give the random state number 7, the accuracy will be 90.95. So here what do you understand? So when you supposed to change the random state, when the random state is changing, the accuracy is also be changing. So that is the big problem in the train test split. In the train test split means that is a simple cross validation, so you are not applying any cross validation. That's why cross validation we are using. If you apply the cross validation on the same thing, on the same, always, even you are changing the random state, you will get the same score. Let's see. If I apply the K-fold from model selection, K-fold from model selection cross val score. Here K4 n splits is equal to 5. In place of 5 you can also be take 10 also. See here, if I have taken the accuracy 100, so random state is 100, so random state is 100, the accuracy 88.711, 88.711. If I change the random state value here 0, even same result 88.71. If we change some value 59, we will get the same score. See, same score. So even here random state is changing. Even the random state is 7, 0, 100 or even 53, even 1, 2, 3, 4. The accuracy is also the same. But accuracy is not changing. But before, but here, without cross validation, every time when the random state is changing, the accuracy is also be changing. So that is the big problem in this. That's why cross validation comes into the picture. Next, if you see, so K-fold is applied to the regression problems. Now we have to apply the stratified K-fold in the classification. For classification, we are taking the diabetes dataset. So here the target variable is outcome, means whether the person has diabetes or not. So here also we, without applying the cross validation, you got the first with the random state 0, the accuracy is 82.468. even if you change the value from 0 to 1, 77.922, 77.922. If you put the random state is equal to 7 here, if you execute it, 79.211, 79.211. So which means whenever the random state is changing from 1, 7, 0, so accuracy is also be changing. So if random state value changing, then accuracy is also changing. So there is no standard accuracy. That's what cross validation comes into the picture. So K-fold. So here K-fold and stratified K-fold. So both undercome the model selection. So this is a regression problem. That's why we are using the logistic regression. We are taking the number of splits is equal to 5. Means here K is equal to 5. Apply the logistic regression. So you got this 76.95. When random state is equal to 7. The random state is equal to 0. If you put the random state is equal to 0 here, the accuracy is equal to 76. So even random state 7, the accuracy will be 76. Even random state is 0, the accuracy will be 76. If you put the random state is 100, they put the random state is 100, even you will get the same score. Means even random state is changing, the accuracy will never be changed. So that is the stratified K-fold. So see, here we are using the stratified K-fold, but in regression, this is a regression kind of problem. So in this regression kind of problem, we are using the K-fold. So this is the K-fold. So this K-fold is used in this K-fold used in the regression kind of problems. But in the classification, but it is in the stratified K-fold. So this stratified K-fold we have to use it in the classification. So the stratified K-fold can overcome the drawback of the K-fold cross-validation method for maintaining the target variable proportion in the training part and the testing part. Next, leave one out. So leave one out cross-validation means simply taking the data. This is observation, this is the instance one. So here first part is used for the so here data. So column 1, column 2, column 3, this is the target variable, and this is the row 1 observation. So similarly row 2, row 3, row 4, like that up to 100 rows, for example. So first time this row 1 is totally used for the testing, and the remaining 99 rows used for the training, and remaining 99 rows are used for the training. This model is applied on this one row of the testing data, and you will get the accuracy 1. Next time this row 2 will be used for the testing, and rest of the 99 rows from row number 3 to row number 100 and row 1 we will consider as the training data and train the model is applied on this second row of the data and you will get the one more accuracy. So finally this process is repeated unto 100 observations and you will get the accuracy is 100, so you will get the 100 accuracies, take the average of the 100 accuracies. So that is the leave one out cross validation. This is the time taken process and this is the it consumes the more resources. There is a drawback of this cross validation. This is the technique used for long before, but nowadays no one can apply these techniques in real time scenario. So for leave one out cross validation, we use the model selection. Leave one out model selection with the cross val score. So, and we are taking the last year regression. That's it. If we take the comparison of the different models, so what I'm doing here, I'm taking the logistic regression, decision tree classifier, SVC, random forest, but here only applying the so first we train the split, apply the elastic regression, you will get the accuracy. This is the general scope. SVM support vector machine. This is the random forest. Without cross validation, this is the score you are getting. After applying the cross validation K-fold, stratified K-fold, so we are applying the stratified K-fold on the elastic regression. You got the accuracy. So mean value will get the 76.957 and SVM 65 and random forest 76. So among the three models 76.95, 76.95, 76, 65. So the accuracy of the elastic regression is more in while apply the stratified K-fold. So this is the practicals in the cross validation techniques. So for my lecture I using these are the references. Thank you.